Cadence functions are a lot like functions in other languages, especially Swift. They are value types, meaning you can assign them to variables and pass them as arguments to other functions. Function arguments can have labels, which provide for clarity at the call site for what each value represents. Up to this point, we were using the REPL functionality of Flow Cadence. To explore functions, we'll start executing our code by sending files to the interpreter. So I have VS Code open on the left and the terminal on the right. I have the file ready in my folder, and we can start typing out our function. The only difference with CDC files from the REPL shell is that you have to declare an entry point where execution should start. You do that by declaring a function called main. So let's go ahead and do that. And let's log hi. Okay. Flow cadence hello. And we see hi. The keyword pub that precedes fun is an access modifier, and it defines public access to that value. We'll discuss it later. For now, just use pub when declaring anything outside of the main function. And let's try it out with another function. Pub fun say hi. So this function will take in an argument, a name. Now see, we have an argument called name, but it has a label too. You'll see how it is nicer to use when calling. And we're just going to log hi. Now we want to combine these two strings. So we're going to use the concat method of string type, and we're going to concatenate it with name. All right. So instead of using this boring old thing, let's say hi with our new function, to fast Floward. All right, let's see if it works. Boom. We now have the basics to start assembling more complex structures. In Cadence, you have two kinds of composite types. Structures, they're value types. Every time you send them, you pass them along, they're copied. And there's resource types. They're linear types. They're moved, they're not copied, and they can only exist once. To declare a structure, let's use an example of a rectangle. So we use the same pub, access modifier, keyword struct, and then the name. All right, let's declare two public fields, width and height. Every composite type, structures and resources, require an initializer where you initialize your fields. Every single field has to be initialized in the initializer. So we take in two arguments, width and height. Set that to width and self.height. Set that to height. All right, so that's an example of a structure. Let's do another example of a resource. Keyword resource and the name of the resource. Let's do a wallet resource. Now our wallet will contain a number of dollars as an unsigned integer, and again an initializer that accepts the same kind of value and sets our field. All right. Now, this is how you declare them. Obviously, we want to use these composite types, so we have to make sure that we initialize them. Let's start with structures, and here's an example. So a square is just a rectangle that has equal width and height. So let's initialize it with 10, height 10. Okay. And we don't have to worry about it. The garbage collector will take care of it once it's out of scope and it's no longer being used. Resources are different. Instead of equals, we use the arrow notation to signify that we're moving the resource from one place to another. We also can't simply allow garbage collection to implicitly dispose of our resource like we did with structures. So let's first initialize an instance of wallet. Let's call it my wallet. Oops. We're using the keyword create when we're initializing resources, and then the resource name, pretty much similar to how structures work. All right, we can try and run this. We get an error notifying that a resource that we created, by the time it got out of scope, it was not disposed of. So we can't have that. We have to explicitly either assign it or we have to destroy it. So we have create and we have destroy. So we don't have any use for this wallet resource, so we'll just go ahead and explicitly destroy it. And now the interpreter would be okay with it. This concludes part 3, where we discussed Cadence functions and Cadence composite types, structures, and resources. And now we're going to move on to part 4, where we start playing around with these building blocks that we've uncovered and look at what we can create next.